Okay, first thing, everybody knew their A, B, and C numbers. Everybody did the exercise. Okay, but you didn't necessarily focus on the process of calculating D, E, F, and G. There's a very simple process, which I talked about earlier. You just add the two smallest numbers of the three, and that gives you D. The next two smallest, that gives you E. And the two largest, that gives you F. Add all three, that gives you G. Very simple. And you want to try to look for patterns like that in what you do. I've said that already, but I wanted to say it. Or the world is stop. Okay. The world's just waiting for my next video. You wouldn't believe how viral these things are. Okay. In the sense that viruses kill people. No. Okay. So, okay, here we have first equation. I've already written out if A, B, and C are these numbers. Then F is 29, A is 8, there it is, right? So an AX would be, not even going to write it out, just use an arrow. This would be AX plus 13 equals, let's see, what is G? That's 29 and 8, I guess that's 37, if I did my arithmetic right. Okay, and you know how to solve that. You subtract 13 from both sides, and then you divide both sides by 8. And that should be pretty obvious. If you don't understand that, go back to the video right near the beginning. I'm saying this, and play back what I just said, and make sure you understand, because it goes back by pretty fast, but I'm assuming people are going to be pretty good with their linear equations. Okay, then it gets a little more complicated. We've got to use distributive law here. So we'll do one step of this. That gives us 8 times x minus 13 equals 16. What do you do with that? You multiply through by the 8. Distributive law says 8 times x minus 13 is 8x minus 8 times 13. That equals 16. Multiply 8 by 13, you get 8x minus 104 equals 16. Add 104. And you get 8x equals 120. 8x over 8 equals 120 over 8. So x equals 15. Okay, then you check it. You put 15 back into your equation. 15 minus 13 is 2. And 8 times 2 is 16. So I actually did one right. Cause for celebration. This was really good. They do a lot of it. Okay. Now, down here, just a little more complicated. It's going to be 8 times 13x minus 16. You get a big number. Why do you use big numbers? I got to multiply with my head. Okay, equals F, which is 29.
Yeah, sorry.
Okay. Well, 8 times 13 is 104. I already did that. 8 times 16 is 128. So I'm just going to put 3 dots down here. We get 104x equals 157. Add 128 to both sides. So 3 dots means something you should write out, but I'm not going to. Okay. And then x dot 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 x equals 157 over 104. Let's see, 104 is 52, 26, 13. 13 doesn't go into 157. So these are relatively prime, so that doesn't reduce. Okay. Now, things I mumbled probably went past you really fast. They're kind of worth listening to when you can pause and ponder what I just said. Assuming I said it clearly and assuming the microphone picked it up right. Let me just double check the microphone's working. Boy, this is so good. It's going to make me famous. And I'll share the same. You know, you all motivated me to do this wonderful thing. Yeah, it's good. Okay. Now, that's all I'll say about this, really. Any last one, it's worth working it up. Give yourself some confidence. If you don't know what to do, well, save it for later. Build your confidence when we find it. Now we're going to go over the syllabus rather quickly. Did I give you the right one? Did I give you the pre-calculus 1 course of study? Well, if you're in my section, you can keep it. If you're not in my section, geez. Yeah. You're not in my section. Give it back so you don't think you're the author. Okay. Okay. I guess I need a copy. Okay, so this tells you my office location. It's either in here or in ISC 220, which is over in the building right there, up in the far corner on the 2nd floor. As far away from this place as you get in that building. Okay, I don't know why they did that to me. No, actually, it's a nice office. It became available. They asked me if I wanted it. I've got a lot of stuff I needed to move out of a storage area. It's a long story, but from when I was doing all distance courses, physics and stuff. So I said, yeah. Haven't been able to use it much because about as soon as I got it set up, COVID hit. It's over there. Okay. You got my phone number there, but use email. I'm probably not going to answer the phone. Okay. I don't like to use the phone because I'm a little bit hearing impaired. And half the people talking to me, I can't understand. They've got to keep saying, repeat that, talk very much slowly, talk a little more loudly, which is a real challenge for somebody who's real timid. Okay. But I don't have a lot of good options. And besides which, even more importantly, you can't do mathematics over the phone. Okay, I can do it through email. So if you ask me a well-phrased question on email, I can get back to you. It's during my office hours, I'll get back to you quickly unless I'm just totally inundated. If not, if it's during my virtual hours. And during my other office hours, I check it regularly. Okay. You got my office hours there. They're virtual office hours. Right now they say 9:40 to 10:40, but I had to come up here and print these. So I had to leave the house about 9:30. So I'm probably going to change them because that can happen. I might have to get up here a little bit early sometimes. Okay. So I might change it to 9:30 to 10:30. But I monitor it pretty constantly during those hours. Every day but Thursday, but often I do it on Thursday anyway, so it's not a bad time. Yeah, I did it this morning. Wasn't obligated to. I was working my email and checking. Yeah, that's usually what I'm doing. Okay. And since I don't usually know what day it is anyway, I kind of do the same thing every class. Okay. Learning support for pre-calculus. We're doing the foundational topics. And the way we're doing it in here is we're trying to get things done here, give you the idea before you see it in pre-calculus. Since pre-calculus classes started, this week, we might be a little behind the curve on that. It's hard to jump out ahead of something that's jumping out at the beginning. But we got to get there. It's a co-requisite course, as you know. You have to be in pre-calculus to be in this course. Okay. So if you were to drop pre-calculus or get yourself removed from pre-calculus, and hopefully you won't do that, then this course goes away on that. Okay. Says you got to have a good working knowledge of prerequisite basic algebra, and that is true. You don't know how to solve these equations. Right now, you don't have much of working knowledge, but something in my experience that you can refresh and learn, relearn very quickly. So the other stuff, not so much, because you probably never knew it, like the laws of exponents. Then, of course, you had an assignment. I think there's an assignment due like yesterday.
I didn't see one.
What?
I didn't see one.
Tonight.
I open math. Got to read.
Yeah.
So what I'll probably do, and email me if I don't, send you a link or the information. I'm going to run a parallel course. Same information, but it's half credit makeup. You got to do these things, okay? You got to be on top of it because this course goes so fast. At the beginning, it slows down after a few weeks. Once we're comfortably ahead, we don't have to stay way ahead of the class. We just have to stay a step or two ahead of the class. And what you get in here is a more foundational version of what you're going to see in class. Just so when you get to your pre-calculus class, you've already seen it, you already know what the basic operations are. You're going to see that today. I'm going to try to give you some foundational stuff for about 3 sections. Okay, maybe I better talk a little faster. Okay. Anyhow, you can read the rest of this, which pretty much says what I've said. And if you have any questions on it, bring it up. Okay. List of major topics that don't necessarily make any sense to you, so I'm not going to read them to you. You're supposed to read it for today, so hopefully you've read it. But if you haven't, here it is. Read it again. Make sure you've read this. And if you have a question about the course, read the syllabus before you ask, because it's likely in the syllabus, okay? I can't think of everything, not everything might be here. But before you ask me a question about the course, read the syllabus. And you can always ask a class, I'll answer the class, but don't email me asking me to explain something that's in the syllabus. If you miss it, okay, I've got a sense of humor. But make the effort. And I might just tell you, that's in the syllabus, read it. Their course objectives are not going to make a lot of sense to you to do the stuff. So I'm not going to read those, but you should read those every week, or at least every 2 weeks, and see what kind of progress you're making. It gives you perspective on what's in the course. Now there's stuff in students with disabilities. If anybody's got a disability, let me know. But if you've got a documented disability, I probably will have already received notification on that. And usually that means you need unlimited time on your tests. Well, you've got unlimited time on your test whether you have a disability or not. Okay. There might be other factors. Somebody has vision problems. Got one person with hearing problems, but I can talk pretty loud, so I do. A little hoarse now, but that should go away. Textbook, free online textbook. The official textbook for free calculus is available through OpenStax. The text that you see on your web page, my Open Math page, is pretty much just the OpenStax text. So like if you wanted to order a copy of that, charge like $50. But if you want a printed copy, you get a nice bound printed copy from OpenStax. It's totally free. You can download that thing and do anything you want with it, as long as you don't violate their copyright laws, which basically says you can copy anything, but if you do, acknowledge it. Read their rules. You will want to have a calculator, but graphing calculator would be of limited use in here. I wouldn't buy a dedicated calculator. You can get Desmos on your device, okay? Don't use it to solve your homework. Solve your homework by writing it up, because you don't learn by watching Desmos do it, okay? But still, they're appropriate uses of Desmos. If you do your homework using Desmos, you're going to fail the course. That's right. It might be. There's a discussion board we might use, we might not. This is a pass-fail course. Get an S or a U. Yep. Okay. If you get an S in this course, then you don't have to take it again, even if you fail pre-calculus. If you pass pre-calculus, you pass this course. I think I said that too. It's right there in the syllabus. I'll say it again. And you get an S grade if you attend 85% of the sections, actively participate, score at least 60% on each test, or attain a 70% average. If you're active, participating, 60%. If you're not active, you miss a lot of classes, miss 1-2% of the classes. With excuse. Without excuse, okay? Now, if you're sick, I think it says something in here. If you're sick, stay away. So, okay? Hope you're not sick. I call sometimes because of allergies. But stay away. You can attend by Zoom. Okay. If you're too sick to attend by Zoom, just say something. Or you'll have the videos catch you on. But I'll ask you to do some things in the videos to make sure you get this homework caught up in reasonable time. Depends on how sick you are for how long. Right. Okay. Tests are graded in every problem on a 10-point scale. We just average the scores and put it on a 100-point scale, so it's a percent. Okay. If you use email, I'll say this, I'm not sure I said it in here. Don't email me from Canvas. Email me using your VHCC email account. You can find that by going to my VHCC. Okay. Log in, scroll down, you find webmail. I think most of you have already done that because I think everybody sent me stuff the right way. I never said don't use Canvas, but Canvas email is just a mess. It doesn't give me a record of what emails I got. I can't do anything with it. As a last resort, go ahead, but I'll say, okay, I got it. I can't open your attachment because it's through Canvas. So you're going to have to send me the attachment, but I acknowledge that you did send it. So I can actually open attachments, but it takes forever. Whereas with Gmail, it comes to my VHCC email address. I just, unless you send me something from your Apple computer, can't open anything from an Apple. Okay. And I'll let you know, you send me something that's not in the right format, send now. You're on time, but send it again so I can give you some feedback. Attendance policy, I've kind of addressed that. With students with disabilities is there twice because some people with disabilities don't see the thing the first time. I don't know. It's in there twice because I accidentally put it in there twice. I think it says the same thing. You got the academic integrity. You don't cheat. Okay. And it's going to be really hard to cheat because your tests are all going to be through the testing center. And we've got the A, B's, and C's. So in these problems, everybody's going to have different numbers. You're not going to be able to just copy what somebody did. Besides, you're sitting too far apart. I also got to okay, fair enough. Okay. So you can read that, and you don't help somebody else cheat either. There's a college-wide emergency. There's a website you can refer to, just the college website, HCC website. In other words, if a tornado comes through and tears the roof off a building. We did have one just a few years ago, not too long ago, did some damage. Wasn't much serious. They fixed it, I think, the next day, but tore some stuff off the building. Just on top of a hill. You know. Tornadoes do happen, even though they're pretty uncommon in this area. You got the VHCC alert system, which you can use to give you alerts, weather alerts. College is closed, check the, you know, if it snows, check the website. There's something on there about the Blackboard supervised study site, which doesn't exist. Yeah, I kind of proofread this, keep missing out. So you cross that out. That stopped working about 5 years ago. And nobody can get it to work anymore. Really good thing that I wasn't teaching 200 students a semester as distance students, because that was critical. So they finally figured out I was teaching 19 courses simultaneously, as distance courses. I developed them over 20 years. Developed them starting in the 90s. So it's just, if the student did something, I'd look at it and give them feedback. Great feedback. And only about 30% of students ever really did anything, and what happened to the rest of them. Still, it was a whole lot of work. And it was critical to have that site. They finally figured out 9 years ago when I had a heart attack. It took about 3 years to hear what I've been saying. Okay. Cardiovascular issues kind of run in my family. If I drop dead, what are you going to do with these 19 courses? Or if I become disabled? Yeah. Heart attack didn't set me back too much. Bypass surgery took a year to get back to lifting full weight. Year goes fast in my age. Okay. Okay, you got the college website, telephone number of the college, emergency text messaging system, right? So that's important information. You'll probably forget it, but it's there if you're conscientious enough to like put it in your phone or whatever, okay? And I recommend that you do, that you know what to do. We got deadlines. If you want to drop this course and get a refund, you better do it by the 14th of this month, which is 2 weeks from today. Not 2 weeks from yesterday. This is the first. 1 and 14 is 15. So 2 weeks from today is too late. Hope you don't do that. But and to withdraw without receiving bad grade, that's November 2nd. That's way off in the future. Okay. Be aware of those dates. If you haven't done substantive work in this course by the 4th, Sunday, isn't it? You better do some substantive work if you haven't already. And if you've completed an assignment relatively conscientiously in the class and done the quizzes, I'm not going to copy it. Okay. If I do drop somebody, I've dropped people accidentally. Because I confused the names. Nothing on me, but you can apply for reinstatement within a week or a few days, whatever it is. A little bit loose with that policy. But apply for reinstatement according to the rules. And if you are dropped, you'll receive an email to tell you about that. For tutoring services available in the MARC. But then trying to drain the swamp dealing with alligators all week and haven't had a chance to get over there and ask what the status is. Hopefully some of the calculus students have the background and be able to tutor, and otherwise my dean is confident we're going to have arrangements. So and there's also online tutoring, free online tutoring. So make use of it if you have, especially if you have questions that aren't in the scope of this course. Okay. Like we're covering fractions, and I'm not going to go to a lot of trouble teaching fractions. If you don't know it, I'm going to tell you get you to it. Okay. If you have a question on graphs on the functions and stuff, then ask me rather. Well, ask the tutors if you want to. If you got a good tutor, you're more comfortable with that, that's fine. You can ask me to. Okay. Basically, I'll teach you this course. I'm not going to teach you all the courses that we don't do this. Also, I think I said it, I post the MDE 60 videos also on your site. I think they're all posted. And those are good for reference. You know, we go into a lot more detail on the stuff that you should know but might not. Okay, and we start with elementary algebra. Get into intermediate algebra around the 1st of October. It seems to work. It's supposed to be an intermediate algebra course, but most of the students don't really know elementary algebra. And that's actually the case at the beginning of most pre-calculus courses. Okay. So I got to teach elementary algebra because I could teach intermediate algebra, nobody learned it. Most wouldn't learn anything. Some of them appear to be pretty good. MDE 64. So I've talked about that course already. So we're going to move on, and I should have queued this up, but it'll just take me a second. I've just got some notes on the topics I need to talk about. I've just listed the topics because I don't want to keep referring back to the MDE site. There we go. Okay. First thing we need to talk about is function notation. If y equals x squared, Say something like y is equal to the function f, which operates on x. This gives us a way of talking about the function. It gives us a notation for the function. So we can talk about general properties of functions without having to talk about this function, that function, or another function. So we can say for any function, for example, if y equals f of x, then 2 times f of x equals 2y. We usually wouldn't bother to say that, but it's just an example of how we can talk about any old function. It doesn't have to be y equals x squared or y equals 2 to the x or y equals 1 over x. Any function, okay? Obviously, if y equals f of x, then 2f of x equals 2y. And 2f of x is actually a new function based on f of x. In a very simple way. Okay. Now, the main thing I want to tell you now, because you'll see more about this notation. Keely, have you encountered this in your course? F of x notation? You have? I mean, in your pre-calculus course? Okay, so rest of you in my course, and you have my condolences for that. So F of 3 is 3 squared. It makes perfect sense because here f of x equals x squared. This x is the same as this x, right? Okay, so if I say that this x is now 3, then this x had better also be 3. That makes sense? So I'm going to ask you just to see if you understand this. If you do, move on a little more quickly, and if not, cool. We need to do. See if you can write these down. First of all, write down f of -4, f of, that's very number, and f of aardvark. If you can figure out what, you don't have to figure out what that means, you just got to follow the rule. Okay, see what you get. Okay. Now you don't have to, I talked earlier about trying to see what everything means. Okay. Right now, I've given you a little idea about what it means. You want to think about it, but the mechanics of it, just to get you started, so when you see it in your pre-calculus class, it's no longer unfamiliar, is just what I did here. Whatever x is goes in here. And then x is that thing. Okay. So f of -4, well, now x is -4, so x squared would be square of -4. Of course, you can work that out. 16. Okay. I noted and what I said earlier, just a few minutes ago, note that seems like PEDMAS is the usual abbreviation for the order of operations. Okay, and you're going to have an assignment on that. It just means you're raising to an exponent, and the exponent only applies to whatever it's attached to, and the exponent is not attached to that negative something. Okay, now if you write it this way, the exponent is attached to what's to its left, which is everything in parentheses. And that's what you would get for f -4. Well, f of a, you're going to substitute your value of a. Your value of a, let's say it's 8. So it's 64, right? What do you think about f of aardvark? Anybody want to give me a no, just because it doesn't make any sense, doesn't mean you can't write it out. There's no mathematical operation that squares aardvarks that I know of. I guess I could invent one. Like my stuff already goes viral and I couldn't handle the thing. Okay. Okay. So I won't do that. Plus, the Aardvark Preservation Society would be all over me if I did something they didn't like. Good chance that would happen. Okay. This stupid camera keeps zooming out. And there is no way, we checked this last year, there is no way to fix it. There's no way to control it. I can't set it and say, stay there. It will not stay. It's like a disobedient dog. Okay. Well, that's function notation. Okay, you're going to have an exercise on that. That should get you started. Okay. The average rate of change, there's an average and an instantaneous rate of change. First thing you see in calculus is, well, one of the first things you see in the calculus course is instantaneous rate of change. You've got a calculus course in your future. This is the most central concept in differential calculus. There's also integral calculus. Most calculus courses start with differential calculus. So most of your first semester, you're dealing with rates of change, but you forget it because you lose the forest from the trees. So I think it's very important to emphasize this concept of rate of change in pre-calculus, because I noticed that people who come out of calculus courses still don't know what rate of change means. And they can't apply it in physics course. Well, my physics course, we're working on that right now. Okay. I've got some really good people who can take that out. But that's unusual. You usually don't see that after the calculus. Doesn't matter who teaches it. teach it. People don't bother in the room. People teach it. Don't know what to do. But one thing we might do is make sure people understand and have the concept in their three calculus course. Now, if you don't have a calculus course in your future, it's still a really important concept. If you're business, what's the rate at which your profit level changes if you change the selling price? How quickly is, change its selling price by 10 cents. Is your profit increase or decrease, and by how much? So there's an application rate of change, just very practical. Okay, well, the rate of change of y with respect to x is changes y over the change in x. Okay, I'll illustrate what that means, but I'll also give you a notation. You write that as delta y, that's root capital delta. Or upwards. Okay. Don't put it downwards because then you're in a multivariable calculus and you're going to get lost. Okay. Put it downward, put an arrow over it, boy, you're into stuff. Okay. I'll be teaching that to the engineers in the spring. And apply it with physics, but that's not what we're doing here. So make sure you write the delta correctly. You probably will, but you're not seeing it. So example. I'm going to take the time to write out rate of change. ROC stands for rate of change. Okay. Average rate of change of y. I think it's important to write with respect to x because y might change with respect to something else. But in this case, we're changing it with respect to x. I'd like to write it out. Average rate of change of y with respect to x. Let's say between x equals 2 and x equals 5. Well, fill in the blanks. X equals 2, what's y equal to? X equals 5, what's y equal to? Record. Okay, got the recorder. If x is 2, y equals f of x, and f of x is x squared, so y is f of 2, which is 2 squared. And you want to write it out that way. You want to write out all the details to reinforce what's going on. Makes sense? It helps you learn it and helps you retain it. Helps you understand it. You know, I got a great analogy for understanding something that I never get right because I don't live mechanism. Okay. Okay, and y equals f of 5. X is 5, y is f of 5, which is 5 squared. Of course, 2 squared is 4, and 5 squared is 3, 5. So, now, to do this, you need delta y, right? Which is the change in y. Again, to write it out to reinforce it. Yeah. What's the change in the y value, I'm going to ask you do s and delta x. And then use your definition of average rate. Tell me what the average rate is. Give you a minute to digest that. Okay, so questions coming up. You maybe have a little trouble interpreting this. Does y change? Is there a difference in the y value we got here? Yeah, it started out as 4 and went to 25, right? So the change in y, subtract 4 from 25. Okay, so it's 25 minus 4. Okay. And what's the change in x, and what therefore is the average rate of change? Okay, again, I forgot to record this. If I write it down. But the change in x, well, x starts at 2, ends up at 5. So 5 minus 2 and that's 3. Average rate is change in y divided by delta y over delta x. Change in y divided by change in x. 21 over 3, which is 7. Now, you're probably going to see in the text average rate, and your text might even leave the word average off of there, which I don't think is a good idea. Next word and it implies what the thing means. I'm not sure they do that. I don't have a whole lot of criticism of the text. But I'm sure they have more criticism than me I have with them. They're part of the world. They're viewing this stuff. Okay, so the average rate is f of b minus f of a over b minus a. Now that's the average rate of change of f between values a and b.
These kind of numbers. Is that using
No, 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 no. These are symbols, so no backward apostrophes. Okay. Good question. But that's, I think those are letters that book users. Okay. Could be x1, x2, f of x1 and f of x2. It's going to take some getting used to. Famous. Okay. Even more than I already had. Okay, so got the x squared function. Here's a table of x values. Here's a table of y values according to the rule. You know how to do that rule now. So these are easy. 1/2 times 1/2 is 1/4. Negative 1/2 times negative 1/2 is 1/4. And I assume you know the rules for selection. Okay. And then up here, I'm going to put 4 up here. Then 2 goes here. Here's 1. Here's 3. Okay, so I have the point -2, 4. When x is -2, y is 4. I have the point -1, 1. When x is -1, y is 1. I have the point 1, 1. And I have the point 2, 4. These are the points I get. And the point 0, 0. In the book then, next these. They're going to know you plurality. Nicer than what I made. Okay. Now, the problem comes if you do the cubic function. I'm not going to have time to do it. I'm just going to tell you what's wrong with that idea of not including the 1/2 and the negative 1/2. They do the cubic function. And it goes through like -8 here and 8 up here. So you got a point way down here and a point way up here. It goes through -1, -1. And if 8 is down here, -1's like here. Okay. But then they do a graph that looks something like this. And the thing that's wrong with that graph is when x is negative is 1/2, 1/2 cubed is 1/8. Well, 1/2 is here. If this is 1, this value sure ain't 1/8. That's like 1/2. It's the wrong shape. And the shape is very important for understanding proportionalities and other things. And the shape should be more like this. Really flattens out. And gets horizontal at that point. Okay, and if you include the 1/2 and the -1/2 and do fractions, another thing they do is all these things can be calculated by hand with fractions. They use calculator decimal approximations. I don't want to see 1/2. I don't want to see 0.25. I want to see 1/4. Okay, I want to see fractions. Unless there's some off the wall front. Now, if Open Math makes you put in a decimal, live with them. But I consider that to be an unnecessary flaw. You're not connecting to the arithmetic, you're doing it by calculator. Okay, you can do the arithmetic, okay?